Welcome back to part 2 of our live training session here with our individual throttle body K24 EP3. In this tutorial, we're going to take a look at creating our base calibration file. In the last tutorial, we began that process and we're going to be finishing up, completing that, setting up our 2-dimensional and 3-dimensional tables such as fuel, spark, variable cam, so we have everything in order to do our alpha N style tuning strategy. Without further wait, let's jump in so we can check this out. Welcome back to our live training session here with our individual throttle body K24 swapped Civic Si. Now, that last training module, we were working on building our base calibration file. We started to go through that process, setting up all of our inputs and outputs under our parameters section. So we've accounted for one half of the calibration process and building a base file. The next half is going to be dealing with our tables. So fuel, spark timing, variable cam control, target air fuel, among other tables. We have to modify and edit. Now, the real big distinction here in setting up and working with and tuning an ITB car is going to be we work with an alpha N strategy. Now, we've talked about that in that last tutorial. That's where we are no longer using map pressure reading from our map pressure sensor, and we're utilizing now our load input to the tables based on throttle position. We can actually see that right here. Moving into the K Manager screen, we see that our upper axes here, or the column axes to our table, is now no longer based on map pressure, but it's based on throttle position, or TPS. So we find that switchover happens if we select it here under our parameters, under our map tab. If we select use modify TPS signal alpha N, that switches over the tables all to utilize an alpha N style signal or throttle position signal. Now, let's go and talk about this real quick. I mentioned it in that last tutorial. I want to cover this again. It is a little bit of a confusing topic and a lot of people get kind of hung up on this. When we select this option here, we're going to find that the map pressure reading coming in on our map pressure channel is no longer actually utilizing the map pressure reading coming from the map pressure sensor. Now, I have the map pressure sensor hooked up to a vacuum source, actually into the vacuum block that I have set up for the individual throttle bodies here. That is no longer actually going to provide a vacuum signal. What we have left over for a map pressure reading is going to come from a simulated or calculated map pressure reading as a function of throttle position. And Honda does this so that we can feed in a more reliable map pressure reading for this alpha N strategy to things like our overrun fuel cutoff. So we have map pressure as a function, or even our closed loop functionality. We have map pressure as a closed to open loop switchover point. It's feeding in a calculated map. Essentially, the map pressure is reading in a linear fashion to our throttle position. And that's where we have our settings right here. So we can see we've configured some things right here. Now, it does affect our fueling. So when we go ahead and if we change our values here after we've tuned our fuel table here, it will throw off your fueling. So don't do that. I like to start off with the default values of 10 and 100, and that works fairly well for pretty much any individual throttle body setup. So again, you have to change it before you do your calibrating and tuning. I would leave these values alone. These, again, work fairly well for me. So I'm going to go ahead and just close that file out here. So what we're left with right now is dealing with all of our fuel and spark timing tables. So again, looking at our ignition timing, looking at our fuel tables, that's TPS, looking at our cam tables, that's going to be based on TPS, looking at our lambda target air fuel tables, that's based on TPS. We need to reconfigure our breakpoints for the table. So what we have here in terms of our header values into the columns, we need to configure that so it has more usable throttle position inputs for breakpoints for our tables, and then configure all of the values in the tables so that it better suited for getting an engine to fire up and tune it on these alpha N strategies. So let's first start off here with our ignition timing and talk about that a little bit. So the breakpoints, if you'll notice, they're all going to be shared between all of our tables. So meaning if I scale the breakpoints out for spark timing, it's going to carry through to every other table that references anything with our throttle position. So what do we need to do here? Let's go ahead and rescale our breakpoints first so it makes a bit more sense. So what I'm going to do here is right click on Edit Load Index, and I'm going to go ahead to my first breakpoint. And here I'm going to change this either to 0 or 1%. So I'm going to go actually choose a value here of 1%, and we can see that's going to be what we start our tables off with. The next value I'm going to do at 3%. The next value I'm going to do at 5%. The next value I'm going to do at 7, and the next value here will be at something like 12. Now, why did I go in such small increments as I'm starting to build out these breakpoints? Well, that's because we have a very highly unlinear throttle position to map style arrangement here. So what does that mean? At a very, very small throttle angle with a very large set of throttle bodies, as I'm finding here, these are 64 millimeter Kinsler ITBs. We're gonna find at something like 5% throttle, we'll find that the map pressure would drastically change, and we need to account for that map pressure movement, essentially the airflow type of movement, how much airflow is coming into the engine, by having a break point at these lower throttle angles. So big throttle bodies, any throttle bodies in general, but big throttle bodies especially, at very low throttle angles will have a very unlinear throttle angle to map pressure / airflow flow coming into the engine. So we want to make sure that we're characterizing the low throttle angle range of the movement of throttle with a bunch of resolution in the table, a bunch of breakpoints. And then once we start to get above that, we can skip the breakpoints and go. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.